All right. Good morning, everybody. Welcome back. So let's pick up where we left on Wednesday. All right. Okay. So that was the last thing we covered on Wednesday. So I showed you how to count the significant figures in any number that you have. Okay. So this concept has to be clear uh, for us to be able to move on to the next topic. Okay, so if it's not clear, go to SI or come to office hours, and then we will get this squared off. Okay, so for today, let's talk about operations and how to correctly express your result based on the significant figures. So starting here with a very simple example, if your car takes 11.7 gallons of gas to drive 278 miles, what's the average miles per gallon? Okay, so very simple math here, miles divided per gallons. So if you go to your calculator, the calculator will give all those numbers here for your result, okay? So we have a lot of digits after the decimal point. And then the question is, are all of those digits significant, or does it make sense to express all those numbers? So of course, the answer is not. And today I will show you the rules to correctly express your final result. Okay, the rules for how many significant figures you should express in your result will depend on which operation is being done. First group, multiplication or division, and second group, addition or subtraction. Okay. Oh, sorry. Ay, ay, ay. Oops. Thank you. Okay, so let's start with multiplication or division. For multiplication or division, you are going to look at the sig figs for each number, and the answer cannot have more significant figures than either of the original numbers. Okay, so look at the sig figs for each number involved in the multiplication or division, and your answer cannot have more sig figs than either of the original numbers. For addition or subtraction, the answer cannot have more digits to the right of the decimal point than either of the original numbers. For addition or subtraction, what I like to do is to stack the two numbers. Make sure you align the decimal point, and your answer cannot have more digits to the right of the decimal point. Okay, so look here at the orange. We have 3 digits to the right of the decimal point, and the yellow has 5. So therefore, your answer has to stop here at 3 digits. Okay, so we are going to chop here, and then you count everything that's to the left. Okay, so because you are going to toss part of the number, we will cover next on some rules to round numbers. But at this point, I want to focus on how many sig figures you need to have in your result. Okay, so the best way to learn this is by doing some exercises. So I want you to try to figure out how many significant figures should be expressed in the result for this example here. I will give you a couple minutes to think about it, and then we will solve together, okay? So focus now on how many sig figures you need to have. I'm not interested in the result here for now. Okay, so go back to the rules to count sig figures. Make sure you get this squared off, and then you add the rules that I just showed you for multiplication or division. Okay, let me switch my screen here. Right. All right. Okay. So always keep in mind of the rules, and then we can add to those rules the multiplication or division. Sorry, multiplication, division, or addition or subtraction rules. Okay, so first case here, first step, we always need to identify what kind of operation we are talking about. Okay, so starting here with division. So for division, we're going to count the sig figures for each number, and the lowest amount of sig figures will determine the number of sig figures in the result. So let's start here with the first number. We have 1, 2, 3, 4, and 5 sig figs for the first number. Okay, so remember, always start from the left, move to the right. Your very first significant figure is the digit different from 0, okay? Now let's take a look at the second number. The first digit is a 0, therefore it is not significant. The second one is also a 0, therefore not significant. And the third one is also a 0, not significant. 3 is your first sig fig. Then after the 3, everything will be significant, 7 and 1. Okay, so therefore we have 3 sig figs. Okay, be very careful with the zeros to the left. So therefore, your result cannot have more sig figs than 3. Okay, so that is the one that's going to determine your result. Second example, we have here a multiplication. So we are going to follow the same rule. Let's start counting the number of sig figs. Always start left and move towards the right. First digit is 2, so that's a sig fig. After the 2, we have a 0, so that's not a significant figure. Okay, so therefore 20 has only one sig figure. All right, be very careful when you have a 0 at the end of the number. Okay, so if you have 20, this is not significant. However, if you have 20 and a point here, just the fact that the decimal point is there, that makes the 0 significant. Okay, be very, very careful with that. And let's count the number of sig figures for the second digit. 1 is significant. After the 1, we have a 0 in between non-zero digits. That makes it significant. And then 3 and 4 are also significant, which means we have 4 sig figs. Our result is going to be limited by the lowest number of sig figs. Therefore, we must represent the result with just one significant figure. Okay. Third example here, now we have addition. So addition and subtraction is a little bit trickier. What I always like to do is to stack the two numbers. And when you stack, make sure the decimal point is aligned. And for addition or subtraction, your result cannot have more decimal points than the number with the lowest amount of decimal points. Okay, so we have 1, 2, 3, decimal digits after the decimal point. And for the number below, we have 1, 2, 3, 4, and 5. So therefore, the result is going to be limited by the number at the top. Okay, so we have to chop the result at this point, and then we are going to count everything towards the left side. Okay. So therefore, you are going to count 1, 2, 3, 4, and 5. Okay, count everything after the limit here. So therefore, your result must have 5 significant figures. Final example, subtraction. So we are going to use the same rule. So let's rewrite the numbers and stack the numbers. Make sure the decimal points are aligned. Then we are going to look at the digits after the decimal point and see who is limiting. So first number has just 1 digit after the decimal point. The second one has 3. So therefore, we have a limit here imposed by the first number. And we are going to count everything to the left of the limit. So therefore 1, 2, and 3. So our result must have 3 significant figures. Okay, so be very careful with addition and subtraction. It's a little bit more tricky than multiplication and division. So we are going to do some practice during the discussion section on Monday to make sure we got this right. Okay. All right.
When you do the subtraction addition stuff, when you chop off like the one section of it, do you still do like the math for it, or do you just like ignore it completely?
So at this point, you will not do the math, but the next topic, we will do all the math, and then we will need to round some stuff if needed. Okay? So when you do the math with everything, and then we will see what we need to chop, and that will tell us if you need to add 1 unit or not. Okay? All right. Okay, so then that brings us to the next topic, rounding off. Okay, we need to round things because there is a limit for the number of sig figures that we need to show, and therefore we need to toss part of the result, and the exchange for tossing is rounding the number. 4 rules here. First one, if the first digit you remove is greater than 5, round up by adding 1 unit to the digit on the left. Okay, so you're just looking at the first digit that you are removing. Second rule, if the first digit you remove is less than 5, round down. That means do nothing, okay? If the first digit you remove is less than 5, do nothing. Just remove it. Rule number 3. If the first digit you remove is 5, and there are more non-zero digits following, round up by adding 1 unit to the digit on the left. And rule number 4 is a little bit of a gray area, so we will follow what the textbook tells us. If the first digit you remove is a 5, with nothing following, round to the nearest even number. Okay, so for rule number 4, you might find different explanations for that. I'm just following what is in the textbook. So let me do the first example here with you, and then I will give you a couple minutes to do the B, C, and D, okay? So we have here the number 5.664515. And I want to express this number first with 2 sig figures, second 3, third 4, and third 4, and fourth 6. So let's see how we do that. So A is telling us that we have to express this number with only 2 sig figs. So let's repeat the number here, 4515. And we need to show just 2 sig figures for a reason that doesn't matter at this point. So always start left and move towards the right. 5 is your first sig figure. 6 is your second sig figure, and that's the point we are going to toss everything into the trash. Okay, so we are going to toss everything here. Look at the number immediately after the line. So the number here is, the digit is a 6. And let's see what the rule tells us to do. If the first digit you remove is greater than 5, then you can toss. In exchange to that, you add 1 unit to the digit on the left. So therefore, this is going to be now 5.7. Okay, so and that's your result. Okay, so you can toss things, but in exchange to that, you either add 1 unit or you do nothing. Okay, to figure out what you need to do, just follow those 4 rules, and that will cover all the cases that we will work with. Okay, so I will give you a couple minutes to work on the remaining, and then I will do with you. Alrighty. Okay. Let's see here what we have. All right. Whoopsie. Okay. For B, we need to express with 3 sig figures. So let's rewrite the number. And let's start from left and move to the right. 1, 2, and 3. So that here is the point that we are going to toss the rest of the numbers. So look at the digit immediately after the line. So that's a number that's lower than 5. So therefore, you can just throw the rest of the digits in the trash and do nothing with the digit to the left. So therefore, you would have 5.66. For C, we need to express with 4 sig figures, 5.664515. 1, 2, 3, and 4. Look at the digit right after the chop. That's 5. So when you have 5, you are going to look at what's next to 5. If you have non-zero digits after the 5, then that means you are going to add 1 unit to the left. And therefore, your result is going to be 5.665. Okay. And then finally for D, 6 sig figures. From left to right, 1, 2, 3, 4, 5, 6. So that's here's the point that we are going to chop. Look immediately after that. We have a 5 with nothing following it. Okay. So in this case, we are going to round the number to the left of the 5 to the nearest even number. So therefore, we have here 5.6645, and then we put a 2 there. Okay, so if you already have an even number before the 5, then I would say do nothing with it. Okay, so you're going to do the nearest even number if you have an odd number before the 5. Okay, so rounding here is a very simple rule. Imagine a scale between 0 and 10. Half of the scale is 5. If you are above 5, you are on the halfway up. So you add 1. If you are below 5, you are on the halfway down. So you don't do anything. Okay, very good. Awesome. So now let's move on to scientific notation. Scientific notation is a very elegant way to express your result. And sometimes it's needed. especially when you have a lot of zeros to the left or a lot of zeros to the right side. Scientific notation use a number multiplied by a factor 10 to the n to eliminate the excessive amount of zeros. Scientific notation is always going to follow the format that I'm showing here on the slide. We have a number multiplied by 10 to the n. And this number has to be a number between 0 and 10, okay? Again, the number in the scientific notation has to be a number between 0 and 10. Zero is smaller than 10, so therefore we add the smaller sign here. All right, and then we have to deal with n. For n, very simple rule. If you move the decimal point to the left, you have a positive n. If you move the decimal point to the right, you have a negative n. Okay, very good. So let's work together in the first example, and then I will give you a minute to work in the second example. So first example, we have the number 1, 2, 3, followed by 4 zeros, and the unit here is meters. And I want you to express this number in scientific notation with 3 sig figures, okay? So scientific notation here will be a better way to write this number to eliminate the excessive amount of zeros that you have. All right, so the decimal point's not being shown here, but you know that is at the end of the number. So now I will move the decimal point in order to get a number between 0 and 10. So let's count the number of moves that we need to do it. So 1, 2, 3, 4, 5, and then 6. So we had to move the decimal point 6 places to the left. If we move it to the left, that's going to be a positive n, and n is going to be exactly the number of decimal places that you had to move. All right. What the heck is that? Okay. All right. So therefore, we are going to end up with 1.23 times 10 to the sixth power. And don't forget the unit here, meters, okay? So three sig figures. The power is the number of decimal places you had to move. Moving to the left, that means a positive power. Second example, we have 0.00123 meters. And again, we are going to transform this number to scientific notation. All right, so let's move the decimal point in order to get a number between 0 and 10. So we need to move 1, 2, 3 decimal places. And now we are moving to the right side. So that means it's a negative n, and n is going to be equal to the number of decimal places that we had to move. So therefore, 1.23 times 10 to the minus 3 meters. 3 sig figs, 3 sig figs, and now we have the scientific notation. Okay, so when you have scientific notation and you want to count the number of sig figures, the 10 to the n power is not going to be taken into account. Okay, so you look only at the number here to count the number of sig figures. Okay, let's switch to the other screen. Okay, units. A result is not complete without the unit. Here we are going to use the International System of Units, or SI system. For each physical quantity, we have a name for the unit and a symbol for the unit. For example, mass in the international system is kilogram and symbol is kg. Each unit has a name and a symbol, and the rule here for the symbol of the unit is very simple. If the name of the unit is after someone famous, the symbol of the unit has to be in an uppercase letter. For example, temperature, the unit in the international system is named after Lord Kelvin. So therefore, the symbol for this unit is an uppercase K. Okay, very good. Let's talk a little bit about dimensional analysis. It's very helpful for remembering formulas and also to figure out equations. Any physical property can be defined in terms of three base quantities: mass, length, and time. Okay. Here I will focus solely on units. We don't need to go deep in the dimensional analysis. So let me give you an example, and I don't want to lose too much time here, and then we will move on. Okay, so for example, oops, speed is defined as distance divided by time. And the idea of the dimensional analysis is to figure out the units for speed, for example. So what we are going to simply do is to use the unit for distance or length, which is meters, divided by the unit that's used for time, which is seconds. Okay, so therefore the unit for speed is meter per second. Another way to represent meters by second is moving seconds to the top, and in exchange to that, we add the -1 exponents there, okay? All right, I don't want to lose too much time here. Just don't forget the units, okay? So the result is never complete if you don't have units expressing it. Okay. So now let's talk about prefixes. Prefixes are a more convenient way to express your results when the numbers have many zeros after or before the decimal point. Okay, so I showed you the scientific notation, which is one way to clean up your results. And using prefixes is another way to eliminate excessive amount of zeros as well. The prefix mega, symbol uppercase M, is going to be used when you have a 10 to the 6 factor. Kilo, attention here, lowercase k, factor 10 to the third. Centi, 10 to the -2, milli, 10 to the -3, micro, 10 to the -6, and so on. Okay. Okay, so I want to do this next problem here with you, and then we will finish for today. The best way to determine the prefix that you are going to use is first to transform this number to a scientific notation, and then we can figure out what's the factor that we need to use. So if you remember here, 123 followed by 4 zeros, we already did here in scientific notation, which is 1.23 times, oops, 10 to the 6th meters. If I want to use a prefix, I'm going to replace the power by a prefix. 10 to the 6th. If you look at the table, is exactly the prefix mega. Therefore, we can take out 10 to the 6th and stamp mega and then meters. So 1.23 times 10 to the 6 meters is the same thing as 1.23 mega meters.
The other would be 1.23 millimeters.
Oh, let's see. You're probably right. So we are going to recycle here what we have done before. So 0.00123 is, in scientific notation, 1.23 times 10 to the minus 3 meters. Okay, so look at the power, go back to the table and see what this power can be replaced for. Okay, so 10 to the minus 3, exactly here, the milli prefix. So therefore is 1.23 millimeters. You were correct. Okay, so pay attention to how you write things. Okay, uppercase M is mega, lowercase m is milli, and they are completely different things. And that's how you can write your result using prefixes. Okay, so I'm just showing you here how to better express a number, either by scientific notation or by using the adequate prefix. Okay, I think that's enough for today. So on Monday we will cover what's remaining here for this chapter and then move on to the next chapter. Okay, so with that being said, I think that's a good point for us to stop. And I hope you have a good weekend, get some rest, and we will come back next week. Okay, bye-bye.
I have one thing.
Thank you.
Yes.
Thank you.
For my